All right, good morning and welcome to Mansa Talker online class. We are still on differentiation, and in this video we'll be talking about three things. Okay, implicit differentiation, or we call it implicit function. The next one is what? Parametric equation, and then progressive differentiation. So the first one we're going to look at is implicit differentiation. Implicit differentiation is simply when differentiating y, anywhere you differentiate y, or in fact anywhere you differentiate the dependent variable. If it is y, put the y the x. If it is z, put the z the x. As simple as that. Watch me now. What do I mean by that? If I have that um, if I have that 2y plus x plus 4x minus 5 is equal to 0, then find the y the x. Okay, as simple as that. Anywhere you differentiate y, put the y the x. That's all. Anywhere you differentiate y, put the y the x. So differentiating of 2y will give me 2. But because it is y I'm differentiating, I must put the y the x there. Plus, differentiation of 4x is just 4. And differentiation of a constant is 0. So differentiation of another 0 is 0. So make the y the x subject. I'm having 2 dy dx is equal to what? Minus 4. Divide everybody by 2. Therefore, dy dx I'm looking for is what? Minus 4 over 2, which is what? Minus 2. You see, as simple as that. So let me give you another example. Example 2. This one does not have any problem. 3x raised to power 3, okay, plus 2x raised to power, plus 2y raised to power 2 minus 2x minus 6y plus 5 is equal to 0. Then we're asked to find, okay, this is raised to power 2. Sorry. You see? Okay, I say find dy dx. Okay, very simple. Like I told you, anywhere you differentiate y, just put dy dx. That's all. So let's go again. Differentiation of this one will give me 6x. Differentiation of this one will give me 4y. Because it is y I'm differentiating, I'll put dy dx. Minus, differentiation of 2x is 2. Differentiation of this one will give me minus 6. But since it is y, I must put dy dx. Plus, differentiation of 0 is 0. And differentiation of 5 is 0. Any constant is 0. So now, bring all the dy dx one place. So I'm going to have 4y dy dx minus 6 dy dx is equal to, or everybody cross, 2 cross, minus 2 cross, I'm having 2. This one cross, I'm having what? Minus 6x. Okay, so factorize. What is common between these two people is dy dx. And what is remaining here is 4y. What is remaining here is 6. Is equal to what? 2 minus 6x. So divide everybody by 4y minus 6 so that dy dx will stay alone. Dy dx staying alone, I'm having what? 2 minus 6x all over 4y minus 6. As simple as that. If you look at numerator, 2 is common. If I bring 2 common, I'm having 1 minus 3x. Denominator, if I have 2 common, 2 outside, I'm having what? 2y minus 3. So 2 can cancel 2. So I'm left with 1 minus 3x all over 2y minus 3. And that is just the answer. Okay. So the next one said, number 3. Number 3 said, if x squared plus 2xy plus 3y squared is equal to 4, then I say find dy dx at x equal to 2 and y equal to 1. At x equal to 2 and y equal to 1. Okay, as simple as that. Let's look into that. So I'm having the first one. I'm having x squared plus 2xy plus 3y squared is equal to 4. Please, remember in implicit differentiation, they always write it in form of an equation. That is how you know that it is implicit. They will write it in form of what? An equation. And anywhere you differentiate y, you must put what? Dy dx. Now, anywhere you have x and y together, it is product rule. Because it's product of two things together. So you apply that product rule there. So what do I do now? Differentiate this one, I'm having what? 2x plus, in product rule said leave the first one. Let me say that 2x is the first one. Leave the first one, 2x. Differentiate y, I'm having what? 1, but I must put what? dy dx. Plus, leave the second one, y. Differentiate 2x, I'm having what? 2. I'm having 2. Okay? Plus, remember what I did here? Leave the first one, which is the 2x. Differentiate y, I'm having dy dx. It's supposed to be 1 dy dx, but it's termed as dy dx. Plus, leave the second one, which is now y now. Differentiate 2x, I'm having 2. Okay, so let's go here. Differentiate this one, I'm having 6y is equal to what? 0. Differentiation of a constant is 0. I hope you know how we 6y. Okay, 6y dy dx. God bless you. Dy dx. Because is y that I differentiated is equal to 0. So let us go now. We now have, bring all the dy dx one place. So I'm going to have 2x dy dx plus 6y dy dx is equal to, everybody move. This one moving, I'm having minus 2x. This one moving, I'm having minus 2y. Okay. So what is common between these two is dy dx. And the remaining thing now is now 2x minus 6y is equal to what? Minus 2x minus 2y all over. Sorry, okay. Now divide everybody by 2x minus 6y so that dy dx can stay alone. So what do I have now? I'm now having that dy dx is equal to what? Minus 2x minus 2y all over 2x minus 6y. Now if you look at this now, something is common. Minus 2 is common, or I can say that 2 is common, depending on the one you can do. Just let me say minus 2 is common. If I bring out minus 2 here, minus 2 divided by this, it will turn to only x is remaining. Minus 2 divided by this, minus minus is plus, so y is remaining. Check it out yourself. Minus 2 times this. Minus 2 times this, correct, all over. If I still decide to bring out the same minus 2 here, I'm bringing out minus 2. Minus 2 divided by this one is remaining minus x, because I'm dividing with minus 2. Minus 2 divided by this one, I'm having plus what? Y. So which can be written as, these two can cancel out. I'm having x plus y all over. Instead of writing minus x plus y, write it as y minus x. So let us now apply. Okay? If we apply, what do we have? What am I applying? 2 and 1. Okay, so let me apply 2. 2 plus 1 all over what? 1 minus 2. So I'm having 3 over minus 1, which is what? Minus 3. Okay? Thank you very much for watching. I hope you like it. Is there any mistake anywhere? Okay? So the next thing we're going to look into, what did I do here? Sorry, 2 coming out here, I'm having 3 here. Sorry, please. 3 here. So I'm having 3y. Yes. This time this is this time this is this. Okay, sorry about that. So I'm having 3 bracket 1. Okay? Because anywhere you see y, put 1. So my answer is 3 minus 2 is 1. So my answer is just 3. Okay. That is that. Now, let's go into parametric differentiation. Now, in parametric differentiation, it's very simple. I'm going to solve it by just giving you an example. Example said that if y is equal to what? Cos 2t. And then I say that x is equal to sine t. Then I say find dy dx. Okay? Find dy dx. Now, they gave us that y is equal to cos 2t. So these two can give me dy dt. So dy dt is what? Differentiate cos 2 something is what? 2 minus sine 2t. Don't forget chain rule, which is what? Minus 2 sine 2t. Okay? So the next one they gave us is that x is equal to what? Sine t. So these two will give me dx dt. which is what? Sine t is what? Cos t. Now, this is where you now use your brain. Use your brain. You are looking for dy dx. Sorry, this is dy dt. We are looking for what? Dy dx. Okay, watch me now. Dy dx is equal to what? Let me take this one first. Dy dt. Okay? Dy dt times this one is dx dt. If I put dx dt, dt cannot cancel out. So I need the inverse of this one. It should be dt dx. So that the t can cancel the t. So to get dt dx from here, okay, dt dx means if you turn this one upside down, turn this one upside down, there is over 1 here. So if I turn this upside down, I'm going to have 1 over cos t. So let me now put it, I'm having what? Minus 2 sine 2x times 1 over what? Cos t. Is it x or t? Sorry, t. Okay. So what do we have now? We are having minus 2 sine t over what? Cos t. Okay. Maybe you may not understand. Let me give another example so that you will understand. 2t here. Okay? Let me give one more example for you to get it right. Okay. Okay, they say that y is equal to 3 sine theta minus sine 3 theta. And they now say that x is equal to cos 3 theta. Then we are now finding dy dx. Find dy dx. Find dy dx. Okay? Now these two will give you what? Dy d theta, which is what? 3 cos theta. Okay? 3 cos theta minus, please note what this is. This is same as saying sine theta raised to power 3. So to differentiate this thing is simply differentiate the bracket, which is cos theta, then differentiate everything, which is what? 3 sine 2 theta. That is multiplied by the power, remove 1 from the power. So the answer to the differentiation of this thing is what? 3 cos theta sine square theta. So please, anyone you don't know, bring it out and do it somewhere. So this is 3 cos theta sine squared theta. Okay, I have gotten the differentiation of this one. Now for these two, dx d theta should be what? The same thing I told you for here. This one should be cos theta all cube, which is what? Differentiate the bracket, which is what? Minus sine theta. Differentiate everything. I'm going to have what? 3 cos square theta. So my answer for that is now what? Minus 3 sine theta cos square theta. Okay. So I'm having minus 3 sine theta cos square theta. So this one needs to turn around. If it turns around, I'm going to have the theta, the x is what? 1 over minus 3 sine theta cos square theta. So let me now apply it now. So my dy dx is now what? Dy d theta times d theta dx, which is what? Minus 3 cos theta minus 3 cos theta sine square theta times 1 over minus 3 sine theta cos square theta. Okay, so if you look at that very well, you see that something is factorizable here. So I'm having that my dy dx is equal to, if you look at this, something is factorizable. The only common thing here is what? Minus 3 cos theta sine. Okay, minus 3 cos theta is what is common here. Minus 3 cos theta is common. So if I divide here, I'm having 1 here plus. If I divide here, I'm going to have sine squared theta. Sine squared theta all over. Then I'm having minus 3 sine theta cos theta. Okay, so what do I have now? So this will cancel this and this will cancel this. So I'm having 1 plus sine squared theta all over minus 3 sine theta. I hope you get it. Okay, sorry, there is squared here. Okay, so one of these take care of one of these. I'm still having cos theta here. So I think that is that. Okay, thank you very much for watching. Okay, the last one is progressive differentiation, which is even the simplest. Okay, I'm going to just show you 2 examples. If y is equal to maybe 4x raised to the power of 4 plus 3x squared x cubed minus 2x squared plus 5x minus 3, then I said find the 5y over the x5. So that's why they call it progressive. It means differentiate this thing until 5 times, get the 5th derivative. So the first one, dy dx, which is what? I'm having 16x3 plus 9x squared minus 4x plus 5. This one is the first one. The second one, the squared y over the x squared, means differentiate that answer you got, which is, I think, 48. 16 times 3, I think is 48. (16 times 3). Okay, 48. So I'm having 48x squared for this one. This one will give me what? 18x. This one will give me what? Minus 4. This is 0. This is the second one. The third one. So 48 times this, I think, is 96. So I'm having 96x, okay, plus 18. This one is gone. The fourth one is the 4y over the x4, which is what? 96. Then the fifth one, the 5y over the x5 is what? The differentiation of the constant is 0. So the answer to this is 0. As simple as that. So one more question, then we are done. Okay, they said that if y is equal to 4 sine squared theta, find the squared y over the x squared. Just the second one. Okay, the first one should be what? Y is equal to what? 4 sine theta all squared. So dy dx is equal to, differentiate the bracket first, which is what? Cos theta. Differentiate everything is what? 8 sine theta, which is what? 8 sine theta cos theta. This one is the first one. So the second one should be what? The squared y over the x squared. If you look at it, this is now product rule. And product rule said, leave the first one. Let me call 8 sine theta the first one. Leave the first one, 8 sine theta. Differentiate the second one, which is cos theta. If you differentiate of cos theta is minus sine theta. Sorry. Okay? Plus, now leave the second one, which is cos theta. Differentiate 8 sine theta. I have what? 8 cos theta. So what do you have now? This time this will give you 8 minus 8 sine squared theta plus minus 8 sine squared theta plus 8 cos squared theta. So if you arrange it very well, you are going to have that 8 is common. So dy dx, instead of writing minus first, start with plus. I'm having 8 cos squared theta minus 8 sine squared theta. So if I bring out 8, I'm having what? Cos squared theta minus sine squared theta. So what do you have now? 8 cos 2 theta. Because I told you that sine squared theta minus cos squared theta is cos 2 theta. Thank you very much for watching. See you in our next class where we'll talk about integration.